In this video, I want to take our logic from last time where we were fetching using async and await from the Pokemon API and displaying that data on the page. I want to take that logic and I want to port it over to React so that we can start building user interfaces that have this asynchronous logic in it. And this will be the stepping stone to us being able to bring databases into our React projects. As soon as we can know how to use that async logic, we'll be able to apply the same concepts and use promises to talk to Cloud Firestore. So what I want to do is, before we even touch code, is map some of this new application out with wireframes. So we're going to build a little application that has maybe there'll be a header, and then a search field, and then a button for searching, and maybe a button for clearing. And when the user comes to this page, they can enter something into this bar, which, let's do a little mock here of that. Same deal. And maybe they search for Pikachu. We've got our two buttons. And once they have clicked then the search button, our asynchronous logic kicks off. So we got to go talk to the PokeAPI server. So that's going to take some amount of time. So what we're going to want to do is display this again. We've got our search clear. But what we want to do in the meantime is have like a loading message appear, and maybe like you could have a spinner instead of just text loading. And then after some amount of time, so this is where like our promise logic is happening in between these two frames. So some amount of time later, one of two things happens. Either that was successful or that errored out. So if it was successful, we can have a little wireframe here where then it says like Pikachu, whoops. And there's maybe an image of Pikachu and then some info about Pikachu below that. So this would be the success. And this would be the error branch. So if it errors out, what we need to do is, instead of trying to display that Pikachu information to the page, we need to display some error information. On the page instead. And so that error will tell the user like, oh, we couldn't reach the server, try again later, or that Pokemon doesn't exist, try a different Pokemon, something meaningful to the user so that the user can sort of modify their behavior and try again. So something as seemingly simple as creating a search field that talks to our database, or a search field that talks to this Pokemon API, actually involves a fair bit of logic on our part, because we need to create this loading interface. We can't just have the application lock up and do nothing while it's going to talk to the other server. And then we need to handle both the success and error gracefully, so that we can show that information when it's successful and an error when something has gone wrong. So as we're going into working on this, I've got some starter files, but what's useful to do is think about the components and state you'll need before we even dive into code. So I'd encourage you to just pause the video for a second, think about it, and then I'm going to start diagramming them out. So if we think about components, we'll need an app component. That'll be our sort of workhorse for containing all of this. We could have a separate form component, but for simplicity, I am not going to break this out into another form, though I would encourage you to do that if you're following along and want a challenge. We're going to have a loading component. We'll call it loading spinner, since we'll use a graphic in there. We'll have our Pokemon data, or Pokemon info, which will be this component that can display all the information about one of the Pokemon. And then we'll also have an error component, or an error message component. And then in terms of state, things that we're going to need to keep track of, and these are all going to be inside of our app component, we need to know when we are in this loading state. So we need some way to tell when we are on this loading sort of frame in our wireframe. So we're going to need something that says is loading. And that'll be a Boolean, a true false. We're going to need something to sort of store the successful information that we've retrieved and the error if there's an error. So we're going to have two other pieces of state here. We're going to have the Pokemon data, and we're going to set that up so it's either going to start as null, so it'll be empty, or it'll be a JSON object that we get back from the server. And then we'll have error message, which we can have be null again, or a string. So we'll use these pieces of state. This Boolean will let us know whether we should be displaying this loading message or not. And then Pokemon data will let us know whether we should be displaying, in the success case, this Pokemon info component here, filled in with the data that we retrieved. And the error message piece of state will be used so that we can determine whether we need to put some kind of error message on the screen. And one other piece of state that we'll need here is the state that stores the Pokemon's name. Pokemon name, and this is going to be a string. Okay, so with this mapped out, we should be able to pop open the starter files and start working through building this application together. So I'm gonna keep my async await version that we wrote in just regular JavaScript handy and nearby so that I can port some of this logic over when the time comes. And I'm also going to open up the starter project here, which is a create React app with a few components and styles set up for us so that we don't have to build this from scratch. So anytime you are grabbing a React project or a project that has a package.json in it, what you need to do is run your install command to bring in all of these dependencies that are expressed in the package.json. So you can run npm install or npm I inside of that project to bring it in. I'm going to go ahead and pause while this takes a minute to install. All right, that finished installing, so I should be able to npm run start to start up this React application. And let's take a quick tour of what is in this project before we dive into actually filling it out. And whoops, the starter file that I've got here has an error because it has part of the solution in it. I'll make sure that that's not in the download, so you won't have to worry about that. Okay, so quick tour. When you're looking at a new project, it's useful to sort of trace the logic from the entry point. So we know that in Create React App projects, index.js is the entry point, and we can see that that is just rendering our application, this thing that's in components app, and bringing in some base CSS that changes the font size, font family, and color. So we can then look at our app component and see what we've got here. So we have this container with h1, and then we have this form that is hooked up to an on search form submit function that currently doesn't do anything other than prevent the default form submit behavior, which refreshes your page, and you don't want that in a Create React app. And then it has a label, enter Pokemon name, with an input of type text, where you can put the Pokemon name. And then it has two other inputs. It has a submit input, which when this is clicked will trigger the on submit for our form. It says search, and then we have another input of type button that has a value of clear. So this will be a button that says clear, and we can use that to clear the page. So if I look back at the browser, this is what we've got currently. Enter Pokemon name, search field, search clear buttons. We have some styling here for the container, the form, the app title, and then we have a couple of extra components that I've added. So I've got an error message component, which whatever you pass as children of this component will show up in this paragraph with this CSS applied to it. And a loading spinner, which accepts a size as a property. And this equals 10 is a way that we can express a default value when we're doing our object destructuring. So this size, if it's provided, will be used for the size of this loading spinner. And that's just some CSS that I pulled from this project and modified slightly for our purposes. And then I have a PokeInfo component here, which this should be where we display that Pikachu or Dragonite or whichever Pokemon data in a nicely formatted way with some CSS and BEM styling for name conventions here that we can bring in when we have that data and we're ready to put it onto the page. So to test out some of these components, I could bring in my loading spinner and my error message. Whoops, and my auto import, I messed that up, so it didn't auto import. So you want to make sure that both of these, when you're using them, you import them up at the top. So I'm going to import error message from error message. Save this, check it out in the browser. So we've got our loading spinner that we can control the size of. Like we could say the size is 100 pixels, 10 pixels. And then we've got an error message component here that uses the children prop. So that the way that this works is anything that we put as a child of our error message component, when we use it here, anything we pass in as a child will be available as this children prop, and we can, inside of the component, display that inside of the paragraph. So this error message component, whatever we put as a child, will show up in red, italics, in a paragraph. Could also grab that Pokemon data. Oops, Pokemon info. Make sure that I import Pokemon info from PokemonInfo.js. And that just has a to-do message in there. So those are the components that we've got going on in this project. We've also got inside of data, I have a JSON of the Pikachu response. This will be useful when we go start building out that Pokemon data page so that we don't have to wait for a response to come back. We can just mock up our application and use this data locally, which speeds up the development process. When we get to that, I'll show you how to do that. It's a process that I recommend doing often when you're building your front ends. And then there's a capitalize words function that will allow us to take like the Pokemon's name or its move list or something and capitalize a string. So that'll come in when we work on Pokemon info. So let's just make sure that we've got the app open. And what I want to do is build out this search form and build out this logic that we created in the whiteboard. So we're going to need all of these pieces of state, and we're going to need to start filling them in and hooking them up to our form. So I always recommend creating your state at the top of your functional components. So I'm going to create state for Pokemon name, and it's going to have a setter function called set Pokemon name set that equal to use state. And the Pokemon name will start out as an empty string. Make sure that I auto imported this as I was typing by hitting tab, but up at the top here, make sure that you import use state. So we've got our Pokemon name. I'm going to copy and paste this a couple of times to make it easier to create the rest of our state. So we've got our Pokemon data and set Pokemon data. This will be that data that returns to us from the API. And we're going to use null as the initial state, which allows us to basically check whether we've got data or not by checking if this is null. We're going to have is loading and set is loading, and this is going to be a Boolean. So we're going to have the application start up in false state because nothing is loading. And when they start searching, we'll flip this to true using set is loading. And when it's finished, we'll set that back to false. And then let's set up our error message. And we could default this as an empty string, or we can default it as null. We just want some way to basically be able to check whether there is no error message. So starting it off as null or empty string is the way that we can do that. You can see as I did that, I've got a few warnings from my compiler. These are warnings because I created these variables but never used them. It's safe to ignore those for now. So I'm just going to close my terminal, hide my terminal window so that I don't have those warnings popping up as we're working through this. So let's do this state first. This is the easy one. We've done this type of thing before. So our input of type text, we're going to say that its value is equal to our Pokemon name. So this state is now deriving what's in this input. And then we need to have a event handler. So we're going to have to create a function. I'm going to call it on Pokemon name change, where we set the Pokemon, set Pokemon name to event.target.value. So this is a function that then we can hook up to our input. So the on change prop here allows us to, when the input is changed, when that event is triggered, run our custom function. So on Pokemon name change. So if we do both of those things, we should be able to, in our browser, type and see that text show up here. And then we should be able, in our onSearch form, just for testing purposes, set up an alert that says you are trying to search for Pokemon name. So if I flip back here and type in Ditto, hit search, you tried to search for Ditto. So this is working. I'm going to comment this out. We don't need this anymore. What I want to do is demo this error message component because we have, if we're in this situation where someone tries to hit search when there's nothing in here, we know for sure that's going to error when we go try to hit the API. So we're actually going to stop it from even getting to that point of doing a fetch when there's nothing in our Pokemon name, and we'll display a custom error message on the page in that situation. So actually, let me get rid of this alert. We don't need that anymore. So we can say if Pokemon name is an empty string, we will go ahead and use our error message here. Whoops, I put the brackets in the wrong spot. Let's do that again. So got an if statement, we got our conditional, and then when that's empty, we can set error message. No Pokemon name provided. Try entering a Pokemon name or number. And then we're going to return here to make sure that any logic that we put after this if statement doesn't run if the Pokemon name is an empty string. So this error message we can now put on the page. I'm going to get rid of the text that's in there and put error message inside of our error message component. So whatever is in this variable shows up in our error message. So nothing currently. And then if I try searching without anything, it'll say no Pokemon name provided. Try entering a Pokemon name or number. So we're now at the point where, this technically works, but this error message is always on the page. It just is empty when there's no text in there. What you often run into is situations where you want to conditionally render something in your JSX. So we only want this component to show up if our error message is not null. And there are a couple ways to do this. We could do like error markup equals, we'll leave that undefined. And then if error message does not equal null, we can say our error markup is equal to this error message. And then we can take this variable and put it on the page. And so when we do that, React, when it's rendering, is smart enough to know that when this variable is undefined, it's not going to put anything on the page. And then when we are in a situation where there is an error message that is not null, we can create that JSX here, store it in a variable, and then put it on the page. So if we run it and we look at our React Dev Tools, at our components here, we can see there's no error message in the page currently. And then if we search, we end up with that error message added to the page. So this is one way to do it. This is kind of the verbose way to do it. The other way that we can do it is taking advantage of the AND operator. So instead of displaying the markup like that, we can put in our curly brackets to allow us to put some JavaScript in here. We can say error message does not equal null. And then put in our markup here. So the way that this works is it kind of abuses the fact that the AND operator will stop running and return the first thing that it hits here that's false. So if our error message is equal to null, this is not going to be executed. We're basically going to get false returned here and put on the page, and React will ignore false and not put it into the text of our page. If this is true, so if our error message is not equal to null, it's going to return and put this on the page, error message inside of our error message component. So if we run it again with the components open, nothing's on the page until we hit search, and then this error message gets put on the page. And there's an even shorter way of writing this is with a variable that is falsy. So falsy inside of JavaScript would be things like null and an empty string and the value of false. That we can use without having to compare it to null. Null is already falsy, so this same logic that we've expressed here will be equivalent to what we had before where we're saying the error message does not equal null. It is very common to see this, so that's why I'm showing you this in React, where you will conditionally render something using the fact that there's this short-circuiting inside of the AND operator. But you can also do it the more verbose way if that's what you're more comfortable with in creating your markup. So just showing you, if I remove that, let's test the page, nothing shows up until we search, and then the error message pops up. And we can use this same thing to conditionally show our loader. So I have another value here that is falsy inside of JavaScript, the value of false. So what we can do is, instead of just showing the loading spinner all the time, we can grab it and say is loading and loading spinner. So if this turns out to be true, this is what's going to be displayed to the page. If this is false, nothing is going to be displayed to the page. So our isLoading is false right now. But if I go into my app here and I look at my state, the fourth piece of state that we created was that loader. If I flip it to true, that shows up. Flip it back to false, that disappears. So we're in a good spot now that we have this loading spinner and error message hooked up to the page to actually start implementing our asynchronous logic. So when we are in this on search form submit, that's when we want to do the fetching that we did before to go pull that Pokemon information and parse the response, grab the JSON, handle any errors that might occur. So what I want to do is grab my previous code as reference. So we wrote this in just regular JavaScript where we had an async function that had a try block that parsed the response, grabbed the JSON and parsed it, and then pulled that data out and put it on the page, which had a catch here that caught any errors that would occur in this asynchronous logic. So a couple things we need to do. First, we need to make this function, our onSearchSubmit, asynchronous. So I just throw async before the arrow function definition here. And so your normal functions like we had in this other project can be marked as async, and your arrow functions can be marked as async. So now that this is async, we could use our await to wait for promises, and we will wrap all of that in a try-catch block. So what I want to do first is set up some stuff that we're going to need before the fetch is kicked off. So we're going to need that URL. Const URL is equal to, and I'm going to grab it here. It is the PokeAPI.com API v2/Pokemon for that Pokemon endpoint. And then we want to put the Pokemon's name at the end of this string. So I'm creating a template string here, and then I can insert Pokemon name at the end. So whatever gets typed in is tacked on to the end of this URL. When we kick off our search form submit here, so when we actually start the fetch, we want to set up our initial state. So we want to make sure that the error message is cleared, because as soon as we start searching for something, if there was a previous error message, like you didn't provide something, we want to make sure we get rid of that because that's no longer valid. We want to set the Pokemon data to null. So if we had Pokemon data already loaded on the page, we kind of want to clear that so that we can be ready for new Pokemon data to be showing on the page. And we want to set our isLoading to be true. So now we're about to start our asynchronous logic, so we want to make sure that this loading is set to true, and when it's done, async logic goes here. When it's done, we will set isLoading to false. So this is where our async logic is going to go, and we know that we need a try catch block when working with asynchronous logic. Inside of here, we can kick off our fetch. So we can create a response variable, and we can await our fetch with that URL that we have just created. We can do similar processing that we did here. So what we did was we checked whether the response was okay or not. And it was not okay when we specified Pokemon that didn't exist. And here we threw an error, bad API request, when that happened. So we want to do that same logic here. When the response comes back, if the response is not okay, we will throw a new error, bad API request. And then we can parse our JSON from that response. So we can say await response.json. Response.json is a promise, so awaiting will pause this And when that response resolves successfully, we will end up with JSON in this variable. If it fails, we'll end up in this catch block. So when we've got our JSON, we can go ahead and store that. Set Pokemon data to this JSON. So in the case, let me remove some of the space here. When things are successful, we get our response and we store it into our state variable up here. So this Pokemon data will be null if we don't have any data, and it will be equal to a JSON object when we do have successful response from our server. Almost done here. What we need to do is also catch those errors and do something to the page. So one thing that's useful, you can console log, but you can also console error, which gives you a nice formatted stack trace in your console window when there is an error. So throwing this error will give us a stack trace, or if the fetch errors, that'll give us a nice stack trace. So console.error here, we are going to put that error into the console so that as developers, we can see the error and all of the details. But in terms of what the user sees, we just need to give a sort of generic error message that says like, oh, we couldn't get this, we couldn't get the Pokemon, please try again later. So we could say maybe try another Pokemon or try again later. This is kind of our generic handling of errors. So that could be that the Pokemon server is down, or the network dropped, or some other problem occurred in the chain from going from our React front end with this fetch to the other server and getting a response back. So there are a lot of possibilities that could be going wrong. So we're just displaying sort of a general error to let the user know to try something different. And then in our console, we can, when we're running the app as developers, check out, what specifically went wrong to sort of handle any errors. Okay, so that was a fair bit of logic we just implemented here. We reset the state. So we made sure there's no error, that there's no Pokemon data that we're loading. This async logic will go ahead and try running a fetch, try getting the JSON, storing that into our Pokemon data. If it fails, it will set an error message. And then after all that's done, we can say our loading is false. We're no longer loading anymore. So one thing that we can do to sort of see what's happening at any moment in time with our application is console log some of those variables. So we could console log is loading, and let's also log our Pokemon data. So anytime our app re-renders, which is going to happen anytime these state variables are changed using the set function, we will see these print out again. So let's flip back to the browser. We can search for a Pokemon. You can see that with each time I typed a letter, the state changed and our app re-rendered. So these are printing out. But each time it's printing out here, we can see is loading is false, no Pokemon data. When I click search, our loader appeared for a split second, and then it disappeared when the fetch finished. So we can see is loading was set to true. Whoops, let's go back up a little bit here. So we can see is loading is true. It re-rendered a couple of times as we changed the state, like clearing the error message. So loading is true, no Pokemon data until is loading is true, and we got Pokemon data back. And we can see this is that JSON object that we had in our regular version that we were able to parse pieces from and display on the page. And let's also test out while we're at it the logic. If we search for something that doesn't exist, that loader appears for a while, disappears, it says could not get that Pokemon, please try another Pokemon or try again later. And then for our purposes, we can actually see as developers, we can open up the console and see, here's where it failed, bad API request in search form. So the error came from, the fetch worked, but the server gave us back a bad response. Okay, let's go back to our code here. We can get rid of this console log. And the next thing that I want to do is we can implement our, let's implement our clear button here. So what this clear button should do when we click on it is get rid of any Pokemon data that we have and also clear this search. So we need a new function. So I'm going to call it onClearClick. And this is going to run anytime we click that button. And we will set the Pokemon data to null. We will set is loading. Whoops. We will set, sorry, what I meant is we will set the Pokemon name to an empty string. So we're getting rid of any Pokemon data that's on the page, and we are resetting this input field, or this variable that's bound to our input field. So on clear click, we want to run that when the click event is triggered from this input, and that the way we can bind that is with the onClick prop. So we can say, here, run this function when that click happens. So we could test it out by typing something in, hitting clear, that field disappears. And then if I were to print out, whoops, not set Pokemon, I want to just print out the Pokemon data so that we can check that that actually gets cleared too. So here I can see that it's null. I search for something like Ditto. It's here we've got specific value back from the API. If I hit clear, that disappears and we're back to null. So our clear button's done. So the last thing to focus on is actually just building out this Pokemon info component and passing the data to it so that the Pokemon info can be in charge of rendering whatever we want from this JSON. So let me get rid of this console log. And what we can do, instead of always displaying this Pokemon info to the page, which is what we've got going on currently, this to-do is always showing up, that Pokemon info component is always there. What we can do instead is do another conditional rendering. So I'm going to put this below the is loading an error message, give myself the curly brackets to indicate that I'm writing JavaScript, and then I can say Pokemon data and render this component. So if this Pokemon data variable is falsy, so it's false or it's null or it's an empty string, or it's the number 0, this won't render. But if it is anything else, it will show up on the page. So now we should see, if we search for a Pokemon, then the Pokemon info shows up on the page. And then what we need to do is actually supply that JSON object, our Pokemon data, into this component. So Pokemon info can accept it as a prop, and then it can go ahead and use that for whatever it needs to do here. So props are that way in React that we can pass information from parent to child. So from inside this app, we can say, here you go, here is the data. We're setting it equal to this variable here, this Pokemon data, which means that inside of Pokemon info, we can grab that data from props.data, and we could console log data here. So as soon as we search, and that shows up on the page, we can see this Pokemon data printing out from our PokemonInfo.js line 6. So we have successfully hooked this up so that it fetches, the loading shows up, and then that data is handed off to our Pokemon info component to actually handle displaying it to the page. The thing that's going to happen when you're doing this work on the Pokemon info component here is that every time you load the application, you're going to have to go type something in, hit search, wait for the fetch to finish, before you can sort of see the changes that you've made. So if we progressively build this up and we, instead of just saying to do put Pokemon info here, we create like an H2 where we're going to put the Pokemon's name. To see any of this happen on the page, we have to go through all of this, hitting search to see our changes. So this is where that mock data comes in, and a process that I encourage you to think about when you're developing is when you're working on a component, can you think of a way to provide it with all the information it needs, sort of in isolation of the whole application, so that you can work on filling it out, styling it, building its logic, and then hook it up to the whole flow of the application. So here, what we want to do is provide this component with this JSON data for Pikachu so that we can work on formatting it and getting everything displaying on the page. And then when that's done, we can hook it back up to our app and the whole fetch flow. So there are a couple ways that we could do this. Inside of our Pokemon info, we could just import that Pikachu data and use that in place of the data here. The other thing that we could do is, and I think that's what we'll do in this video, is inside of our app, instead of specifying that the starting state is null for this Pokemon data, we'll go ahead and import the Pikachu data and temporarily say that that state is equal to the Pikachu data. So I'm going to import Pikachu data from data/Pikachu data.json, and instead of null, just temporarily for testing purposes, pass that in. So our Pokemon info component is always going to show up, and that data is always going to be there as a prop. We don't have to go through this search to get anything showing up on the page. So now we can flip back to our Pokemon info and start building out this component. As we're building this out, we want to keep the Pokemon API documentation handy. So I could go to PokeAPI.co, go to the docs, and then here are the different endpoints, the different URLs you can talk to. We could ask about berries, about evolution, about items. Specifically, we're looking at the Pokemon endpoint, and we are looking at the Pokemon within that. So this is that URL that we've been specifying where we put in a name or an ID after the slash. This gives us an example of what gets returned, and then it has a description of all of those fields so that we know what they are. Like it tells us that height is an integer, and it is the height of the Pokemon in decimeters. So to start with, and I'm going to go through this quickly because we did this in the last application. We just did it in regular JavaScript. But to start with, let's throw the ID and the name on the page. So we know that that is going to be inside of this object, and it's at the root level here. So we would just say like data.id or data.name to pull out those fields. So the name would be data.name, and the ID be data.id. And then inside of our H2, we can say name and then ID. So Pikachu 25, and maybe let's format this. I'm going to put the ID in parentheses, and let's throw a little hash in front of it to indicate that it's a number. So Pikachu number 25. And we can use the function that I provided in utils, the capitalized word, to actually get the Pikachu to be uppercase. So when we go ahead and display this to the page, we could just capitalize words and make sure that we import capitalized words. Utils, capitalized words. And whoops, I am noticing my spell checker has caught that I've made a typo here, and I can actually, if I open up my window, my terminal window, I can see that it's telling me, capitalized words is not defined because I have misspelled it. So making sure that I spell it correctly here. Now we can see Pikachu with a capital P. So we can refactor this a little bit to this process that we're doing where we're pulling out each variable one at a time. We also saw way back when we were making the quiz game that we could do destructuring. So if we want to pull out fields from an object and put them into variables that match the same name as the field, we can use this syntax where we just say const, and then we have the object destructuring and the names of those fields. So this line does the same thing we were doing on these two lines, just does it in a shorter syntax. So this should still work. So I'm going to use the object destructuring. Okay, so continuing to build this out, we can start using some of the BEM classes that I've defined. So we have the Pokemon, which is the whole container class, and then we have some child elements using the BEM syntax where we have a Pokemon list of things, we have a Pokemon name, a Pokemon set of images, and a Pokemon image. So what we can do is use that class of Pokemon underscore name to apply that here, which centers that header. We can create a div with a class name of Pokemon images. So this is a container for multiple images. And then we're going to want to put the front image and back image of the Pokemon here. So to figure out how to get access to those, same deal, we got to look to the documentation. You can either look at your sort of JSON object here and inspect it in your browser, or go back to the documentation and look through so we can see the place where that is stored. Just collapsing a bunch of other things here so that we just have sprites expanded. We can see here's what you'd get back for, I believe this is Butterfree, yeah. So we'll have something similar where we can grab the back default or front default from the sprites object. So using dot notation, we would be saying data.sprites to get this object, and then data.sprites.front default or back default to get these specific URLs. So I'm going to use my object destructuring here to get the sprites object. And then I can reach into this to get front default or back default. So I can destructure sprites into front default, back default. And this front default it's the same thing as if we had said front default equals sprites dot or data dot sprites dot front default. I'm just destructuring here to make the syntax a little bit cleaner. So we pulled out sprites and then we pulled out front default and back default from that sprites object. So my source is equal to front default and my source here is equal to back default. And if we hooked that up correctly, we should see two of those images show up. If there's an error here, that means we've made a typo. Like if instead of front default, we misspelled this and said like front default without the L, that one image isn't showing up, and we would have to start inspecting to see what's happening here. And that process would be console logging. So we would just start console logging variables. We could look at front default and see if there's anything going wrong there, and immediately see that it's undefined and know that, oh, we made some mistake when we were getting to this variable. And we would hopefully then catch our typo. Okay, so we got our two Pokemon. We're also getting a warning that image elements should have an alt prop with meaningful text or an empty string if they are decorative images. So these images, we want to have an alt prop here to make them accessible. So if someone goes to our site with a screen reader, they could still tell what's supposed to be there, even if they can't actually see it for themselves. So we can throw an alt tag here and here. And I'm going to use a template string to say front view of name and back view of name. Give this a save. Those warnings are gone, and if I were to actually inspect one of these elements, we can see front view of Pikachu, back view of Pikachu. Let's put some of the stats on the page for the Pokemon. So if we look back at our API, we have a width, or we have a height in decimeters and a weight in hectograms. So we'll kind of put those on the page here. We'll say maybe an H3 that says stats, and then we'll create a UL and an LI that says height in decimeters and weight in hectograms. So this list, let's also apply the class that I created. So class name is equal to Pokemon __ list. Check it out. So we have that list style, the bullets have been replaced with emoji, and we just need to go ahead and grab those stats and put them here. So we see that it's stored as height and weight, and again, those would just be like we access name, where we'd say data.weight, data.height. I can throw them into my object destructuring here and say weight, height, and make sure that those are spelled exactly as they are labeled as fields inside of the data. So we can put the weight. Whoops, don't need the $, we just need the variable, and height. So weight 4 decimeters, height 60, whoops, height 4 decimeters, weight 60 hectograms for Pikachu. And I think the last thing that I will do in this video, and I'll leave the rest as like a exercise for you all to follow along with, is I want to take one of these lists of information that we get back. So we have a move list, we have a stats list, we have a types list. We could pick any of those and go ahead and display those in a list on the page. So maybe if we look at our Pikachu data specifically here, and we look at the, which one should we do? We'll do the abilities. So Pikachu has 2 abilities. One is static and one is lightning rod. We want to be able to loop over this and display each of those in a list item on the page. So we're going to need to go into our data, grab the abilities, which is an array, and then do a map to turn each of these objects here into a list item with lightning rod and static in each list item. So I'm going to create a new H3. We will say this is the abilities. I'm going to go ahead and create another UL with a class name of Pokemon list. And this is where we want to do our mapping inside of here with our array. So I'm going to destructure abilities. And again, this needs to match exactly what the name is in our object that we got back from the API. So this is now an array. So we're going to map, and each time we map, we're going to get this passed into our map function. So this object. So I'm going to say abilities.map, ability object in this arrow function here. And if I just return a list item with nothing in it, we should at least see 2 show up on the page, one for static and one for lightning rod. And then what we need to do is go into this ability object and actually grab that ability name and put it on the page. So if I look in here again, each ability has multiple pieces of information about it. So if I expand one of them, I can see that each one has an object called ability that's stored under the label of ability. We have isHidden, which is a Boolean, and slot, which is a number. And then if I look in my ability, I can see, okay, here's the actual name, static, and then here's a URL that takes me to more information about that ability. So this is my ability object in my map, and I need to reach into the ability and grab the name field here. So just to make that a little bit more clear, we can always at any point just console log the ability object. So this is what we're getting from our map, and then I need to go into the abilities using dot notation, or go into ability using dot notation, and then grab the name. It's going to be ability object dot ability dot name to get this field back, or the value of this field. So let's pull this out into a variable. Let's say the name is equal to ability object dot ability dot name, and then put that in our list. Whoops, I keep accidentally putting these $signs in here. Muscle memory. Okay, so there we go. We got static, we got lightning rod, and then we've got a warning that each list needs a unique key. And in our situation, each ability should have a unique name, so we can just use that for our key as well. We can say the key is equal to the name, and that warning should go away. Static, lightning rod, no warning. So I'll leave it as a challenge to you to fill out more of this from the data. In my solution for this project, I also mapped over the types that we get back. And I also looped over the moves that we get back. So like for Pikachu, you could see there's one type for Pikachu, electric, but some Pokemon have multiple types. And then for moves, Pikachu has a whole bunch of moves that are listed in here that you can display to the page. What I want to do now is just circle back to sort of connect this form to this data, and then maybe polish up one or two things about it. So now that we've finished working on this Pokemon info, we can go back to our app and get rid of this mock data that we were using. So instead of specifying the state starts as Pikachu, we can say null, and we can get rid of that import since we're no longer using it. And our whole application, the logic should still flow where I can search for a Pokemon, kick it off, and this will work for whatever Pokemon data comes back. Because they all have the same sort of general structure, you know, what we wrote for Pikachu should work for Dragonite or Eevee or whatever Pokemon we search for. Okay, and then the last little thing that I want to do is our search button. I can keep clicking it multiple times while this search is running. And normally what you want to do is prevent the user from being able to initiate multiple searches. So if I go to my network tab and I change my simulated network to be a slow network and click search, I don't want the user to keep hitting search while that loading spinner is there. So let me go back to online here with no throttling and pull up my components. So what we want to do, and this is actually really easy to do with the setup that we have, is inside of our app, we want this button, the submit button, to be disabled when the application is loading. So when that async logic is happening. So disabled, we can pass in a true or false value. If it's true, it's disabled. If it's false, it's not disabled. And is loading is a variable that is true when we are loading something. So this will disable when we're loading. Let me turn my network down so that we can see this running. Whoops. So that button's disabled, and a disabled button will not allow the form to be submitted or the on-click handler to run. So we've essentially disabled the search functionality for a whole form by just disabling that button. You know, the other cool thing that we can do in React is it makes it really easy for us to, like, what if instead of saying search here, we wanted to say searching when we are loading and search when we're not loading something. We can say is loading, searching, otherwise search. So if we check that out in the browser and I click search, I got to fill something in so it doesn't error out. And let's turn down the network again so that this runs more slowly. We can see searching, and then we're back to search. So we can add a lot of like little polish things now that we know we're loading that sort of improve the user interface, like changing the text here and also disabling the search. And this is a ternary operator, which I think we've talked about before. It's a mini if statement. So if this is true, this is what gets put here. Otherwise, this is what gets put here. You'll see it often inside of React used for little things like this, and you'll see it very commonly in just JavaScript projects in general. Okay, phew, we're done. We did a lot in this project, and we made a fairly complex little application compared to what we did last time when we were just doing vanilla JavaScript and we were just printing out the response to our console window. So we learned how to implement all of this asynchronous logic that handled the different states that our application could be in. So like the loading state, the success state, the error state, and learned a few tricks to be able to control what shows up on the page. Like we learned about and the short circuiting that allows us to conditionally put something on the page only if this is true. So if is loading is true, this gets put on the page, otherwise nothing gets put there. And we learned how to kick off our asynchronous logic inside of our onSearch form submit and mark it as an async function so that we can use our await and control the state before and after that asynchronous logic runs. As you can see, this is a lot more complex in terms of the logic that needs to run because there's a lot more going on here than our other version where we were just printing things out to the console. So take some time, make sure that you understand the pieces that are in this application because these patterns that we used here will apply going forward when we want to say pull data from a database or put data into a database. When we start integrating Cloud Firestore into our projects. So I'll leave this project here, and next time we'll start looking at how to actually interact with a database and pull information from a database.